Hi everyone, welcome to my channel, Maths Made Easy with Terry in 10 minutes. So we're going to be talking how do you differentiate trigonometric functions, okay? How do you differentiate trigonometry? I have another video on basic trigonometry and advanced trigonometry, so you can try as much as possible to look at that videos first or the playlist. But basically, what I just want to do here is I'm going to give you some trigonometry functions and show you how to differentiate them, okay? So before I move forward, please don't forget to like, share, or subscribe. And don't forget to click the notification bell so that when I post new videos, you'll be the first person to know. So here, we're going to be looking at how do you differentiate trigonometric function. So for instance, you have y is equal to t ax, okay? So usually I'm going to represent the trigonometric function with t. So where the a is equal to the constant, okay? So where a is a constant and the t is equal to the trig function. Does that make sense? Or the trigonometric function, okay? So for instance, if you have something like e.g., we have y is equal to sine 5x, and you're told to differentiate this, okay? Or it's possible as well is that you could have it as y is equal to kt ax, okay? So in this case as well, instead of having just one constant, both a and k are constants, okay? Then t is equal to the trigonometric function. All right, so in this example, for instance, so you could have something like, let's say, instead of having that, you can have y is equal to 7 sine 5x. Are you seeing it? Okay. All right, so you can see that the trig function is sine. You have a constant in front of it or in a function there, and you have a constant. So you have something like this, and you were told that they want you to differentiate this, and how will you go about this? Okay, so if you want to differentiate this, there are 4 rules or 4 steps to take. All right, the 4 rules or 4 steps. The first one is that you have to first differentiate the trig function first. So that is, I'm referring to the t, okay? So that means the t here. So the trig function, you have to differentiate it first. And the trig function, the t, and to give you the derivative of it, okay? So to give you the t prime. So let's assume when you differentiate the trig function, the answer you got was trig prime, all right? Then after you've differentiated that, the next thing is that you have to then differentiate the elements or the expressions. So you can call it the elements. Some people call it the expressions. Okay. In the brackets. Okay. So anything that you find in the brackets. So like in this case, what we have in the bracket here is AX. Okay. So anything you find in the brackets, you differentiate it. Okay. Then when you're done with that, the next thing that you then multiply. You then multiply step 1 and 2 together. Okay. You then multiply step 1 and step 2 together with the original expression. Okay. Now, but step 4, okay, step 4 only occurs when you have a k, all right? So if there is a k, all right, so if you have k, that's where you go to step 4. But if there is no k, you stop at step 3. So for step 4, if there is a constant, okay, so if there is a constant before the trigonometric function, Okay? Then multiply the uh the constant with the result from step 3. Okay? Multiply the constant with the result from step 3. All right. So before I start explaining down, let me just quickly just explain what I mean with this with a general formula, all right? So I want to just use the general formula like I do in the other mechanism to explain the rules before we start going deep into the trigonometry function themselves. So the first one we have is y is equal to tax, okay? So we have y is equal to tax, okay? Where the t stands for trigonometric function. So what I'm saying, step 1, is that you have to differentiate it. So what happens now in step 1 is that the trigonometric function you have there, you have to differentiate it to get the t prime. Does that make sense? After I differentiated that, you have to differentiate the elements in the bracket as well. So the elements in the bracket here, that's for step 2, is ax. And when you differentiate ax, it's going to give you what? A. Are you seeing it? Now, step 3 said that you have to multiply step 1 and step 1 and 2 together with the original what? Expression. So that means we have step 1. So that means you have this. It's going to be A multiplied by the trig function and the original expression in the bracket, ax. Okay? So that is it. Then, therefore, we're going to have dy over dx will be equal to a t prime ax. Now, but, okay, if the question was y is equal to k t ax, all right, so if the question was this, for instance, what you will now do is that you now have step 4. Okay, the answer you have here will now be multiplied by what? K. All right, so it's now going to be a t prime ax, and that will give you what? K a t prime ax. So this will be the dy over dx. All right, and that will be the answer for that. So that is how you do it. Okay. So quickly, before we go start taking some examples, I just want to just explain some trigs. So when you differentiate a trig function, what will be the derivative for that? Okay. Now the first one I'm going to start with is sine and cosine. Okay. Now for sine and cosine, there's a very funny relationship between both of them. Okay. So what you do is that when you differentiate sine, the answer you're going to get is cosine. So when you differentiate sine, it will give you cosine. When you differentiate cosine, it's going to give you minus sine. Are you seeing it? And when you differentiate minus sine, it's going to give you minus cosine. And when you differentiate minus cosine, it's going to give you sine. So usually in some textbook, you will see them write it like SC minus S minus C. So when you differentiate sine, it will give you what? Cosine. When you differentiate cosine, it will give you minus sine. When you differentiate minus sine, it will give you minus cosine. And when you differentiate minus cosine, it will give you sine. Okay? Now, this is the relationship between both of them. So when you're differentiating sine, it will give you cosine. Cosine will give you minus sine. Minus sine will give you minus cosine. All right. Now the next one is there are other derivatives that you need to keep in mind as well. So there are other trig derivative. Okay. So there are other trig derivative you need to know. Uh, All right, the other trig derivatives you need to know. So for instance, one of them is that when you differentiate tan x, the answer you're going to get is what? Sec squared x. So when you differentiate tan x, it's going to give you sec squared x. When you differentiate cosec x, when you differentiate it, it's going to give you minus cosec x cot x. So when you differentiate cosec x, you're going to have minus cosec x cot x. They have proof for this, but we're not going to talk about them. So the next one, when you differentiate sec squared, or you're gonna let me start with sec x. So another name for sec x, sec is the same thing as 1 over cos. So another name for sec is 1 over cos x. All right. And when you differentiate that, it's gonna give you sec x tan x. Now for cosec, cosec is the same thing as 1 over sine x. Okay. So I've talked about this in trigonometry. I think either the advanced or the basic, one of them. So we've talked about that when you see cosec, cosec make 1 over sine, and when you see sec, it's 1 over cosine. So maybe I can write it clearly so that for those writing, you can see it and not get confused. So when we say sec x means 1 over what? Sine x. So either you see 1 over sine x, or you can see cosec x. They ask you to differentiate it, and that will give you minus cosec x cot x. Also, if you have cot x is the same thing as saying 1 over tan x, or some textbook can write it as cos x over what? Sine x. So it's the same thing. So you can have it at cot x, the same thing as 1 over tan x, or cos x over sine x. And when you differentiate cot, what you will get is minus cosec squared x. Okay? So these are the trig identities you need to know. So when you differentiate sine, it's cosine. The reason why I'm showing you all this is because of step 1. So remember, step 1 said you have to differentiate the trig function to give the trig, the derivative of the trig. Does that make sense? So when you differentiate sine, it's cosine. Cosine is minus sine. Minus sine is minus cosine. And also, when you differentiate tan, is sec squared. Cosec, or 1 over sine, is minus cosec x cot x. When you differentiate sec x is 1 over cos, when sec x is the same thing as 1 over cos x, and when you differentiate sec x, it's going to give you sec x tan x. And cos x is the same thing as 1 over tan x, or you can say cos x over sine x. And when you differentiate it, it's going to give you cosec squared x. And also, just to also know, tan x, let me also write it there. So just in case for people writing, tan x, you can also break it down as well. So tan x is the same thing as saying sine x over cos x. All right. And when you differentiate this, it's going to give you what? Sec squared x. So basically, cos x is the inverse of tan x. So we talked about this in trigonometry. All right. So please go back and look at the video on trigonometry. And I've talked about all this already. All right. So let's get cracking and solve some questions now. So let's pick an example. So let's say we're told that we need to differentiate y is equal to sine 2x. Okay, you're told that you need to differentiate y is equal to sine 2x. Now, step 1, we need to differentiate the trig function, right? So in this example here, step 1, the trig function we have here is sine. And now when you differentiate sine, what will it give you? If you go to the sine, it's going to give you what? Cosine. All right. So we're going to have cosine. Okay. When you differentiate sine, it's going to give you cosine. So I'm going to write it as cos. All right. So that it will be easier for you to write. So when you differentiate sine, it will give you cosine. Then the next thing, step 2, After doing that, the next thing you're told to do is that you have to differentiate the elements in the bracket, okay? And what is the element we have in the bracket here? We have 2x. So when you differentiate 2x, it's going to give you what? 2. Then step 3, we then need to multiply it. So it's going to be 2 multiplied by cos, and the original one there, 2x. And this is going to give you dy over dx is going to be equal to 2 cos 2x. As you can see, in this example, we can't go to step 4 because there's no constant in the front there. All right, let's pick another one. Let's say we have another question. We have y is equal to tan 1 over 2x. So usually some textbook will put this in the bracket, okay? Some will not, okay? But if you want for your clarity, you can put it in the bracket so that it will look exactly like this, so it will be easy for you. But if you don't put it in the bracket, you should know that the tan is affecting all the elements here. So we're going to start with the first one, step 1. The tan, when you differentiate tan, what will it give you? It should give you what? Sec squared. All right, so when you differentiate tan, it's going to give you sec squared. Step 2, we have the elements in the bracket. So we have 1 over 2x. And when you differentiate 1 over 2x, please go and check the power rule. It's going to give you 1 over 2. Then step 3, we then have to multiply. So it's going to be 1 over 2 times sec squared. And the original elements here, 1 over 2x. So dy over dx is going to give you what? 1 over 2 sec squared, 1 over 2x. Okay? And that will be that for that. All right, let's pick some more examples. So let's assume we have y is equal to 4 cos 3x. Okay? So 4 cos 3x. So step 1, we have cosine. When you differentiate cosine, what will it give you? You go back to the sketch. Cosine will give you what? Minus sine. All right. So when you differentiate cosine, it's going to give you what? Minus sine. Step 2. When you differentiate 3x, the elements, so like I said, you can put this in bracket if you want to. So 3x, when you differentiate 3x, is going to give you what? 3. Step 3. We then have to multiply this. So it's going to become 3 multiplied by minus sine, then the element here, 3x. And this is going to give you minus 3 sine 3x. But remember, in this case, we're having a constant here. So we have to do step 4. So remember, in step 4, we're told that if there's a constant before the trigonometric function, then multiply the constant with the result from step 3. So now, to get the final result, step 4, we have to do step 4. Step 4 now, which is going to be dy over dx, will be equal to 4 multiplied by minus 3 sine 3x. And that will give you what? Minus 12 sine what? 3x. And that will be the answer for that. Okay? So if there is a constant, you have to add one more what? One more step. All right, so let me add one more as well and see how far we can go. So if we have y is equal to cosec 3x or cosec 3x squared, depending. So let's work with cosec 3x and see if we can get that. So step 1, the first thing you have to do is that you have to convert cosec, okay? So when you differentiate cosec, so you go back, cosec is minus cosec x cos x. So it's going to give us minus cosec. But because we have it here, it's going to be 3x cos x. Okay? So that is that. Step 2, differentiate what is in the bracket. We have 3x. And when you differentiate 3x, it's going to give us 3. Then step 3 is going to be 3 multiplied by minus cosec 3x cot what? 3x. Okay? So you can see we have the minus here. Then when you now multiply this, you're going to have dy over dx is going to give us minus 3 cosec 3x cot 3x. Okay? And that is that for that. Let me add more. I feel like adding more questions as well. So let's assume we have y is equal to 3 over 2 minus sine 6x. Okay? So like I said, try as much as possible, okay? Try as much as possible. You can pause the video, try and solve it. Then when you come back, you now check it again and see if you get the same answer that I did. All right, so let's go. So we have this, so step 1. So you can see in this case now we have a constant. So this is the k in front of the trigonometry function, right? So what I'm going to do, I'm going to solve this one normally, then I'll multiply it in step 4. So we have minus sine. And also for minus sine, if you go back, if you have minus sine, it's going to give you minus what? Cosine. So we have minus cosine, give you minus cos. Step 2, okay? What you have again in the bracket, you have 6x. So you have 6x. When you differentiate 6x, is going to give you 6. Step 3, you then have to multiply. So it's going to be 6 multiplied by minus cos what? 6x. And this will give you minus 6 cos 6x. But remember, you have a constant here, so you have to do a step 4. Step 4, you have to then multiply the 3 over 2 with the answer from step 3. So it's going to be 3 over 2 multiplied by minus 6 cos 6x. And 3 over 2 times minus 6 will give you what? That means dy over dx is going to be equal to minus 9 cos what? 6x. And that will be the answer for that. So I hope it's the same answer you got. I'm going to pick one more, and then I'll give you some exercises to try. So let's assume we have y is equal to cot 3x divided by what? 2. Okay? Cot 3x divided by 2. So step 1. So before you go in, remember I told you when we're talking about reducible fractions, I told you that you have to ensure it's back to an index form. So before we start, I need to rewrite this question in an index form. So in this question now, it will now be y will be equal to 1 over 2 cot 3x. Are you seeing it? So now I can now solve with this. You can't solve with that, now you can solve with this. So that means the 1 over 2 now is the k, and this is it. So we can now start solving. So we have step 1. When you differentiate cots, we have cots. You go back and check. Cot will give you minus cosec squared. Okay? Will give you minus cosec squared. All right? Then step 2, we have 3x. When you differentiate 3x is going to give you 3. Okay? Step 3, you then have to multiply. So it's going to be 3 multiplied by minus cosec squared 3x. And that will give you minus 3 cosec squared 3x. Then because we have a constant now, we have to multiply step 4. So step 4 now will be 1 over 2, the constant, multiplied by the answer I got from step 3, minus 3 cosec squared 3x. And that will give you the y over the x now will be equal to minus 3 over 2 cosec squared 3x. And that will be the answer for that. All right. Okay, so that will be the end for the exercises I'm going to use while solving this question. Let me give you some to try, okay? So you can try this. So what about if you were told that y is equal to 4 sec 3x? Number 2, y is equal to 5 tan x cubed. Number 3, y is equal to 7/3 cos minus 4x. Number 4, we have y is equal to minus 4 sine 5x squared. And number 5, we have y is equal to 2/3 cot minus 3x. So for each of this, I want you to now find the dy over dx, okay? So like I always say, you can write your answers in the comment section and let's see what you got. And if you are with your friends, you're doing studying, you're doing group study, you can solve it and compare answers. But if you guys are still struggling, you can send me an email, or if you see me around, you can just stop me and we'll talk about it. All right. And that is that for this mechanism of differentiation. How do you differentiate trig function? So basically, you differentiate the trig function, you differentiate the elements in the bracket, you multiply both of them, and if there's a constant before a trig function, multiply the constant with the result from what? From step 3. Okay, the next one we're going to talk about, I'm going to go straight now into finding the tangent and equation of a tangent. Okay, how do you find a tangent and equation of a tangent with differentiation? So it's very important that you subscribe, because we're going to go into a deeper level of using differentiation in calculus. So I would advise that make sure you subscribe and click on the notification bell. So when I post the next video, you'll be the first person to know. All right. So I'll see you soon and have a nice day.